As early as 2004, scholars proposed the concept of high-entropy alloys. High-entropy alloys refer to alloys composed of 4 or more elements in equal atomic proportions, and these alloys typically possess excellent mechanical properties. Cobalt, chromium, iron, nickel high-entropy alloys exhibit an excellent combination of high strength and high toughness. But current research on these alloys is relatively limited. Nowadays, the mechanical properties of materials are usually characterized by unidirectional loading methods. However, in practical applications, materials are often subjected to complex stress states, making the parameters derived from unidirectional loading methods unreliable. Therefore, researchers have developed electromagnetic biaxial Hopkinson bars to test the dynamic mechanical properties of materials under complex stress states. Firstly, a cruciform specimen suitable for large plastic deformation is designed in this paper. The designed specimen was verified through finite element method, which meets the design and experimental requirements. The feasibility of the specimen was further confirmed by experiments. Secondly, under uniaxial tensile loading, the results have good coincidence. Therefore, this HEA is considered to have tensile isotropy within the slice plane. The HEA exhibits obvious strain hardening behavior. After dynamic uniaxial test, the yield strength under dynamic uniaxial tensile loading increases by 53%, and the tensile strength increases by at least 21%. Thirdly, for quasi-static biaxial tensile test, the digital image correlation technique is used to measure the strain, and the figure clearly shows that the area of the calculated maximum strain is the fracture position. This HEA exhibits obvious strain hardening behavior under quasi-static biaxial tensile loading at 2 ratios. Then, for dynamic biaxial tensile testing, the experimental process is recorded using a high-speed camera, and the strain is measured using digital image correlation technology. Compared with quasi-static biaxial tensile test, the mechanical parameters are improved. The deformation process of cruciform specimen under 4:2 ratio dynamic biaxial loading is shown here. We can clearly observe the entire process from initial deformation to destruction. Finally, the von Mises and Hill 48 yield criteria are employed. The results indicate that the von Mises criterion underestimates the experimental stress, while the Hill 48 yield criterion can well describe the yield behavior and strengthening behavior of the HEA under dynamic and quasi-static biaxial loading. Thank you for watching.